Welcome to the permissions video. I'm going to show you how to read and edit permissions of files in Linux. At first it may seem a little complicated, but I'm going to try breaking it down and make it look a little simpler. So first let's look at how to list permissions and read them. All you're going to do is go to terminal, make sure you're sudo so you can see all the files, and do ls-l. So that'll list all the files with its assigned permissions. So the permissions are right here, right? It looks a little complicated, but it's pretty simple. The first letter, the L, D, or the dash represents what type of file it is. So for an L, it's a symbolic link, which just means that this file right here actually will just point to this file when you open it. D stands for directory, like a folder. And a dash just stands for a normal file. It's not a folder, it's like a text file or a picture. After the LD or the dash, we have this long line of RWXs. I'm actually going to make it a little bigger for us to see. Okay. The way you read this line is first you break it into three parts. So the first RWX is one group, the second RWX is another group, and the third RWX is another group. The first set of RWXs stands for the file permissions of the owner. So for apple.txt it would be root, and for desktop it would be the Cyber Patriot user. The second set would be the group. So these three represent the permissions for the group of the file. So root for Apple and the Cyber Patriot group for desktop. And the third set is for the other user. So the one who didn't create the file or the user who isn't in the group. Now I'm going to tell you what RWX stands for. The R stands for read. Alright, can the person view the file using cat or Pico? The W stands for write. Can someone edit the file through Pico or Nano or Vim? And the X stands for execute. Can someone run the file, right? So in cases of scripts like list.sh, right, the other user doesn't have an X, there's just a dash, which means he's not given the permission to execute the file. But in the case of the owner, it has an RW and an X, which means he can do everything with that file. Usually the owner will have full access to the file. The group may have just read and write permissions or read and execute permissions, and the other user might just have read or execute permissions. So now I'll show you in a real example how permissions affect other users. So I have a user called Tom on the computer. So I have to sign in with Tim, right? Now if I list all the files, I have list.sh. According to the permissions over here, the other users, in this case Tom, does not have permission to execute the file, but he can read the file. So if I were to try reading list.sh, I can see what the script actually does. But if I were to try running the list.sh script, it says permission denied. But as root, if I were to run the script, it executes and I can see everything in the etc directory. Okay. Now let's say we wanted Tom to be able to execute list.sh. We're going to change the permissions, and at first it seems complicated, but it's actually very simple. Before we begin, make sure you're either sudo or you're the owner of the file, because if you're not, you cannot change the permissions of the file. Real quick, I'm going to pull up a chart and leave it there. I'll explain it as we go. So the command we're going to use to change the permissions is called chmod. Now I'm going to show you the simplest way to change permissions using chmod. There are multiple ways. You can use letters and plus or minuses. I'm going to show you how to do it with numbers, and this is where the chart comes in handy. So looking at the chart, we can see R, W, and X, right? And each have a number below it. 4, 2, and 1 in binary, okay? The easiest way to explain this is the read permission is 4 points, the write permission is 2 points, and the execute permission is 1 point. Now when you add these points together, it equals the permission they get. So in the case of the owner of the file, the 7 is given read, write, and execute permissions. 4 plus 2 plus 1 is 7. For the group, it's only given read and execute permissions. 4 plus 1 is 5. And for the other user, it only has read permissions, so 4, and then you only give it a 4. Now to show you what we're going to do with list, we want to give Tom read and execute permissions, right? Tom is an other user, so the read permission is 4 points and the execute permission is 1 point, so we would give him a 5. But we also need to put numbers before the 5 to represent the owner and the group permissions. So let's give the owner full permissions, which would be a 7, right? 4 plus 2 plus 1. And let's give the group the same permissions as Tom, which is read and execute, right? So we'll give it also a 5. So we have 7, 5, 5. 7 for the owner, 5 for the group, and another 5 for the other user, right? So once we have the 755, you want to name the file permissions we're trying to change, which is list.sh in this case. Once you do that and execute it, do another ls-l, and we see that list.sh now has execute permissions for other users before it didn't. So now when we try to run list.sh as Tom, we can. So it seems a little complicated, but try practicing it with your own files. Give some files execute permissions and try running it as another user, or give the group specific permissions and try running it like that. This chart is super helpful. Try memorizing it or looking into it more. And the simplest way to remember is read is 4, write is 2, and execute is 1, and you just add those up depending on which ones you want. I hope this helped you learn more about permissions and helped you tamper with some of the file permissions on your computer.